喂，这边应该是先开了。NASA 这边表示，NASA 这边表示是12点半，也就是北京时间是下午1点半要开始直播。空差这边的直播设置显示还蛮奇怪的，好像就是在那个点火的时候它这个时间设置肯定是有问题，因为它的点火是21分嘛，1点21分北京时间的话，不是那个东部时间1点21分，那么北京时间是2点21分，所以它这个时间设置肯定是有问题的。不过所以我这边选择的是提前1个小时开啊，以 NASA 这边为准。我们这边的录制要不要开始一下吧？录制就开始一下吧。我也不知道这次会有多少人看，反正这次聊起来应该还是比较有意思的。把这边稍微调整一下。这边录制开始。那好，各位好，那这边开始录制。那么这次来看的任务还是比较有意思啊。那么名字简称 DART，这个缩写可以直接译为飞标啊，估计可以被戏称为飞标任务。那么它全称呢其实是 Double Asteroid， Double Asteroid， 等一下我翻下来吧，就说是 Double Asteroid Redirection Test。这个意思呢，就是双小行星系统呢是的，这个 NASA 开了的重新导向任务啊。空差这边没有开，那么把 NASA 这边拉过来，把 NASA 的拉过来。
Now one planet strikes back. For the first time in our planet's history, NASA will test an asteroid.
什么鬼？
It's the first planetary defense method of its kind.
稍等一下，
NASA's Double Asteroid Redirection Test will intentionally ram itself into an asteroid and alter its orbit forever.
那么 NASA 这边直播我就先看了，看来空差那边没有开，很奇怪。那么就继续来说啊，看这个片头也是在说这个。那么这个任务的主旨呢是有意的将这个小飞行器呢撞向一个即将靠近的地球的双星系统之一啊。那么，这作为是未来的一个小行星抵御防御措施的一种手段演示吧。那么它的潜在意义就是说，如果未来有哪个小行星有可能撞到地球，对吧？而且我们有足够的时间反应的话，那么很早的时间就发射一个小飞行器过去，撞向那个小行星，然后使它轨道偏移，然后可以错过地球。那么这是它的基本的主旨的意思啊。那么这个算是一个验证性的实验。
Now, right at the top, let's talk about this. Are there any asteroids threatening Earth that we know of?
Now, thankfully,
对，
there
这
are
边
no
现在加
known
进来说，这
asteroid
边估
impact
计
threats
是
to
肯定
Earth
是
to
会
keep
用 NASA
tracking,
的
and we
源，
don't
但
know
是
of
现在
any.
NASA 开的
It's the
早一
one
点，
that we
空
don't
差那
know
边不
about
知道
that
为
we're
什么
concerned
他
about.
们那
That's
边没
why
有开，
NASA surveys
所
the
以我也是
asteroids,
提前设
searches
置
for them,
720P 啊，
and does a test like
反
DART
正是
to
不
have
可能有
that in
更
the
高的
toolbox.
清晰度了。
Okay, and this asteroid DART is going to hit. What's the story there?
Well, the asteroid Didymos does not pose an impact threat to Earth. It keeps its
那么这次目标
distance,
系
stays
统
like
呢
it gets no closer
是
than 3.7
是两个
million
小
miles
小行
to
啊，
Earth's
是有一
orbit.
个双星系
So
统
that's
的。
what makes it
那
a
么中间那个
fabulous
大的那叫
test
Didymos， 然后那个小的
situation
呢
for
叫
DART. We can go
Dimorphosis。
safely test an impact,
大的那颗
the
应该
kinetic
是
impact
我
technique,
记得直径是
and Didymos is the perfect laboratory for that.
Okay,
780
and
米
this
左右，那么小那
spacecraft
个应该是
is
直径
this
160 米
something
左右
that。could one day save the planet?
Well, what's nice
那么它
about
这
this, I
边
mean, it's a nice mature technique,
我有点在
kinetic
自己讲
impact. You just
啊，
impact
在这里
something.
放
But
2个小
now
模
we're
型，
actually going to test it. So
你可以
this
看到
is
这
going to be
2
really good
个
to have something in
小
the
行星的
toolbox
大小比
that
例
we've
啊。
actually tried taking it from modeling to an actual test.
Well, it is certainly exciting
其
just to hear
实
you talk about
其
it.
实像
And
这
when
种
that
任务
moment happens in the fall of 2022, when that
本身的话
impact
其实就是
happens,
给那
that's
个
going
小
to be
行
quite a
星
moment.
赋予一个额外动量来去改变
All
它的
right,
轨道。
Kelly, thank you so much. And
而
there's
这里难
so
点
much
是
more
在
to
于
discuss about asteroids, planetary defense, and the DART
就
mission.
是
So
你的
let's
小
get
行
right
星飞行
into
器的
it
质量
with
非
a
常
quick
小啊，虽然你
breakdown
撞的
of
速
the
度可以很
DART
高，但
spacecraft.
这个质量差距还是很大的。
DART
就
has
这
a
次
mass
的
of
小行星质量应该
670
是
kilograms, about a golf
总
cart
飞行
size or
总起飞
vending
质量应该是
machine
670
size
公里啊，670
machine.
公
It
斤
uses。
但是你
hydrogen
看那个
thrusters
小
for
行星当中
propulsion
小的那一颗，也就
and
目标的
rolled
那
out
一颗呢，应
solar
该也是
arrays
有
for
500万
electric
多吨的一个质量，所以质量差距是非常大的。所以你要撞出一个可以观测的效果，其实是比较困难的。所以他们其实是这个任务花了很多心思啊，包括目标的选取，以及它的观测手段都是花了一些心思的。这个应该是这次的飞行器运到范登堡空军基地的一个镜头。看吧，这次起飞地点呢，刚才其实有一现场画面是加州的范登堡空军基地4号，应该是几号发射台来着
？Engineers made it to DART spacecraft inside its protective fairing to this SpaceX Falcon 9 rocket, which you see here, and DART's at the top of the rocket. It was then rolled out to the launch pad at Space Launch Complex 4E, where it is now waiting liftoff at 10:21 p.m. Pacific, 1:21 a.m. Eastern Time. Now, as we follow pre-launch operations, we also have some cool stuff to show you along the way.
其实大部分里面是空的。它其实有意思的一点是，当时这个任务还是一个比较低成本的小实验啊。原本是想设计做成其他任务的一个次力载荷的，所以它比较小。这个演示。但是呢，其实空差在19年竞标的时候得标的时候啊，它不光是以最低价竞标得到了这个任务，而且是主动提供了，它会给一个专车的包送，而不是做一个次力载荷，就是专门把整个火箭都用于这个任务。所以其实这个 DART 这个任务是额外得到了一个待遇提高的，还是蛮有意思的一个小故事。
Well, at the moment, Daryl, everything is still go for launch. We listened to polls just a few minutes ago internally with the spacecraft team and NASA engineering. No red flags. Everything looking right on course. Want to introduce our commentator who's making his debut launch commentary tonight, Denton Gibson with the Launch Services Program. Your mission manager, no stranger certainly to Falcon 9 and missions like this, but this is your first time in the commentary booth, so welcome.
Oh, thank you.
他们刚才也提到，现在的天气应该是全部是放晴状态。
And the teams on console have been going through their steps methodically since a little before 7 o'clock this evening Pacific time. There is a live view of the Falcon 9 rocket at Space Launch Complex 4E to your advantage on Space Force Base. And in less than a minute, we expect to hear the NASA launch manager Omar Baez poll the NASA team for launch readiness and readiness for propellant mode to go ahead and proceed with that. That is all go. That will begin at T-minus 35 minutes.
Right. And the reason why you hear this poll at this point in time, because there's so much going on much later in the process. So they try to have the poll early so that way the team can focus on the telemetry and focus on the data coming from the rocket and really pay attention to everything that's going on leading into those last few minutes.
还有这次的发射基地呢是范登堡的SLC-4E 发射台。
Our propellant loading poll starting with NASA CE.
NASA CE is go.
SMA.
SMA is go.
SMD.
SMD is go.
NASA mission manager.
NASA MIM is go.
LSP.
LSP is go.
Team's ready to proceed in the cryo tanking.
So what you just heard was the NASA launch management polling the various NASA teams
刚才其实已经听到了一个投票的一个通讯啊。然后这里其实我说燃料加注一投票呢，还是要再过一会儿。它其实有好几轮投票，一个是刚才听到的应该是 NASA 这个团队的内部投票，之后应该还会有空差和那个 NASA 双方的一个投票。等那个双方投票之后的话，还有空差内部的一个技术投票，那就是我们比较经常熟悉的发射前38分钟的燃料加注一投票，应该是有很多轮投票的。那么刚才听到的反正是 NASA 方面的各个团队应该全部是给出了 Go 的一个投票。
We have a lot of familiarity with this booster because we actually launched this for the first time on Sentinel-6 almost a year ago today.
Yeah, so happy anniversary, Sentinel-6.
那这个任务呢，也算是空差的第一个就正儿八经的升空，或者说是interplanetary 就行星际的一个升空任务啊。那么之前 NASA 应该说是真正比较算得上的就是猎鹰重型的首飞，就是把特斯拉发到了一个超越火星的一个太阳轨道里面。但那次是没有一个具体的轨道目标，也是只要发出去，发到越高越好就好，它也没有特意的一个任务或者说是目的地。这个其实算上这个呢，其实算是真正意义上的一个空差的一个正儿八经的升空任务。
They'll be able to see some kind of change.
Right, it's a unique mission in that there's an
他们这里
astronomical
现在提一个
component
比较
to
有意
it
思的问题啊，
when
就说
DART
是
impacts
这次
the
作为
moon
一
of
点是
Didymos
任务嘛，
Dimorphos
最重要的一
in
点
the
就是
fall
你
of
撞完之后，你
2022.
要
It
有
will change the
观测到
orbital
一个确信
period
的
of that little
那么
moonlet.
轨道的变化。
But from the Earth,
这
it's
说是为什么
just
是
a
选取
point
这
of
个
light, but
小
that
行星
point
双
of
星系
light
统的原因啊。
varies in brightness
这
because
有很
that
多原因的。
moonlet travels in front of and behind Didymos, and so that can be measured, and that
首先
rate
几点吧，
of
一个
that
说
light
是
going up
你
and down is what
小
we're
行星
going to
飞行
measure
器
the
所带的
change
动
in
量，
that,
其实
and
说白了
that's
还是
how
有限
we're
的。
going to see
所以你要
exactly
看到
what
一个
DART
明显的
did to
明显的
Dimorphos.
变化的话，你选取的目标应该就是要一个动量相对比较小的一个目标。那么首先呢是要体积和重量质量比较小，那么这是为什么选一个小行星两颗小行星当中的一个小的原因，小的那一颗的原因。另外是希望它的速度比较小。那么这里呢也是特意选取了双星系统，因为它们的一个互相绕行速度其实是比较慢的。那么像这次的这个 Dimorphos 绕行 Didymos 的一个绕行速度大概其实10厘米每秒的一个速度，其实是相当比较慢的一个速度。那最后呢，应该是指望能够改变它的0.1，那是1厘米不到每秒的一个速度吧。还是0.1秒每，应该是0.1，应该是0.1厘米每秒的速度改变，最后目标是。但你也可以感觉到，其实这也是一个算是1%左右的改变，但也是一个非常小的变化。你要是直接去测量速度呢，是非常困难的。这里的一个比较聪明的做法呢，就是因为你选取了一个双星系统，所以你可以通过它们互相绕行的周期变化来验证它的一个速度变化。这也在解释这个问题啊。从观测角度来讲，无论是天文还是说是航天，或者说其他角度来说，或者说一般的物理意义上的测量来讲，你对速度或者距离的测量，其实都是比较困难的。其实最方便的，或者说物理上做到最精确的，能力也比较强的，就是对时间测量。所以你把一个速度的变化，通过一个周期变化的方式来进行测量，要远远方便，要就是大方便的多。这是为什么一定要选一个这种双星小行星系统的原因。那么这次呢，双星系统的一个绕行周期应该是11.8小时左右啊。那么撞击之后呢，应该可以改变它的周期，达到大约70秒左右的变化。那么70秒左右的一个变化呢，其实是非常容易测量的。你可以想象，你这段是每几秒钟拍一张照片，然后你持续观察大概2个周期左右的时间，你就可以拿到一个非常好的测量。
And try to push it away in such a way that it will change the orbit of the asteroid and it will move it.
如果你想象，如果说你是撞击它的，如果说是针对它的太阳绕行速度、公转速度来想的话，就非常困难，因为它公转的速度也是数公里每秒。数公里每秒的一个速度，那么速度改变会非常小，同时它绕行的周期是2年左右嘛，那也意味着你要观察大概就是说至少3-4年才能拿到一个结果，而且这个结果改变就更加微小。所以选取一个双星系统其实是一个非常聪明的做法。
While the launch and spacecraft team are busy preparing for liftoff, the mission operations team located across the country in Laurel, Maryland, is preparing to communicate with the DART spacecraft after an hour-long flight on a Falcon 9. Let's bring in Samson and Rainey now to find out what they're working on.
对，空站那边一直没有。
Hi, Daryl. I'm at the Johns Hopkins Applied Physics Laboratory, which has a number of historic milestones in space. We're talking about the first mission to orbit Mercury, the first flyby of Pluto, and of course, here we are with our next major milestone with DART.
还是在介绍它的实验室吧。
Missions Operations Control, which is essentially the nerve center for the spacecraft after launch.
这块的话，应该是
It controls everything
空站
from
那边的燃料加
propulsion
速
to
头
the
杆应
power
该是
supply. Let me give you a quick lay of the land here. If you look behind me in this corner, there is a U-shaped configuration. That's called the command pit, and it houses the flight controllers as well as the mission operations manager. Now, flanking the command pit on either side are the consoles for the subsystem experts. Right now, the team is basically looking at their consoles and making sure all systems are green or a go for launch.
那么这边也算是一个内部的控制室，反正也是看看各参数是不是放心的状态。
Basically in charge of the overall health
对，你看这个主持的前面其实放了一个这次DART 飞行器的一个小模型，两边展开呢是这次它使用的一个太阳能板。它这个使用太阳能板其实也比较有意思啊，就说是其实国际空间站最近安装的几乎是同款，其实有些小改动，但基本是一样的，就是这种卷轴式展开的太阳能板，算比较新的一种产品了。其实整一个 DART 它的它除了那个验证行星防御系统的这个理念之外呢，它还做了一个很多新设备的一个展示平台，也算是对这个任务充分利用它的价值吧。那么其中之一就是这个太阳能板。那除了太阳能板之外的话，它还应用了一个新的电对系统和一个新的雷达通讯装置，以及一个新的一个图片定位系统，这些都是一些新的一些硬件啊，作为一个新产品在深空环境中的一个验证使用。
So after the spacecraft goes through those automated sequences successfully, the team will then take control of the spacecraft. Navigation systems will be engaged, and the team will then bring the DART spacecraft to a default orientation, which includes, most critically, making sure that those solar rays are pointed toward the sun and gathering energy for the journey. So as you can see, a lot is going to happen tonight, and so the team expects a graveyard shift. But stay tuned, because later on in the show, we're going to come back and talk to some of the engineers and scientists and learn more about the mission. So stay tuned. Thanks, Daryl.
基本没什么太多听他讲的内容，不过，
It was a beautiful day today on the Central Coast of California. And fortunately, we also have a beautiful launch weather forecast. So let's take a look at the satellite, and you can see the clear areas we shift from day into night. That's California in the center, of course, and that peninsula there, that's where we're launching the rocket. There are clouds to the north and to the west, but the area around the central part of the state where we are fairly clear with only some high cirrus clouds from a weak cold front that did move into the area and lower the temperatures here. Now, the Space Launch Delta 30 launch weather officer Max Rush says that this will bring elevated winds both on the ground and in the upper atmosphere. So they are watching those closely, but overall, take a look at this launch day forecast. It is nearly perfect. 90% the wind is 18 miles per hour. That is the gust out of the north-northwest. Temperature down to 48 degrees, so it's a little chilly out there. The concerns are winds and offshore clouds, as you saw some of that cloud cover over the Pacific. Now, the Space Launch Delta 30 weather team will be monitoring all of those winds and conditions as we move forward. Now, the winds on the ground and the winds up in the upper levels of the atmosphere, this is always being monitored by the Space Launch Delta 30 team.
还有一个就是高层风的问题，高层风的问题因为是你通过雷达预报是比较难预报的，一般都是要通过就是在发射前放气象观测气球来进行观测的。那么应该是一直都有在做，那么现在应该还是够的一个状态。
Meteorologist of the Space Launch Delta 30. Good to see you.
就是又掐到什么地步了？
This is the nerve center for weather forecasting.
那么应该是掐到他们的天气预报的一个部门，应该是天气监测站。
Twice a day, all of those sites release a balloon. So we're putting out the data for not only national.
刚才提到像高层风啊、高层切变风，尤其和高层风这两个因素是比较常见的火箭发射装置的原因。 这种天气呢，这种天气因素都必须要通过气象气球来进行观测。这边也说了，他们一般是每天2次进行放飞气球。
So I understand you're going to be releasing a balloon in just a few minutes. Yeah, absolutely.
他们说这里这个肯定是事先录制的嘛，说他们应该是很快就要放一个气球。让他放这个气球。
10 seconds. I feel like the biggest hit in the park.
这个评论网友刚刚说这次任务是给恐龙报仇。
Perfect.
这次应该不算是一个非常正儿八经的让小行星的公转轨道改变啊，但其实是一个放小型化的一个演示实验。其实也可以想嘛，就是说这次发射的，就是载荷的总起飞质量只有670公斤啊，其实是非常小的。如果你要正儿八经做这种有意义的小行星轨道改变的话，我觉得你的重量应该还是要上升将近一个数量级吧，会相对好一点。
Let's check in now with Raquel Villanueva, just about 5 miles away from us at a launch viewing location with more. And Raquel, looks like you got a little bit of a crowd behind you.
本来来说的话，
That's right, Daryl. There is a crowd of about a couple hundred people behind me getting ready and braving the chilly temperatures to watch this launch. And right next to me is DART Deputy Mechanical Engineer Lisa Wu to talk about how the spacecraft was built. Thank you so much for joining us today.
Of course, thank you for having me.
Tested and designed.
That is a great question. So DART was built from the inside
这个应该
out.
是
We started with components on the inside,
他们有在排气了，反正我可以确认现在燃料加注在进行当中。
System or algorithm built by APL. Woo! That's basically what's going to autonomously take us to the asteroid. So once we tested everything on the inside, we closed up the box and we started doing everything on the outside. So we installed and integrated our solar arrays, our ROSAs, as you will roll out solar arrays. And then at that point, afterwards, we put on our Nexi engine, which you can see here in the video.
这是那个它的所谓的 Nexi
thruster, which is pretty cool.
新一代的电推。
我们
这是刚刚说的卷式的太阳能板。
And from there, we had to take it through a series of very rigorous testing,
有一个
including vibration testing and thermal vacuum chamber testing. All of this was really cool. One of our last things we installed was our Licha cube from our Italian friends, and then we put it in our shipping container and shipped it from Maryland all the way out here to California.
制造研制流程吧，包括什么？大概来说就是它就是核心做完之后，包括里面的一些自主运行系统啊等等。内部封装好之后再装外部装置，包括就是刚提到太阳能板、通讯装置和外界的那个推进器啊等等，然后封装之后运到那么发射场等等。
But with pandemic and all the restrictions, it was
这个是
really
有点让
hard.
我联想到上期里面那个女主。
We did things very virtually. We did procedures online. We did shift work, and in the end, the awesome team we had made a spacecraft. So, hey, that's why we're here today.
It's great to see you here now.
虽然很难，但最后就是组装好了一个飞行器。
And I will send it back to Daryl.
Kel and Lisa, thank you both so much.
你看左边画面，其实就是刚才可以看到，火箭边上是有排气现象的。那么因为空舱使用的是超低温液氧作为它的氧化剂嘛，那么所以说它注入氧化剂的时候，其实会因为火箭吸热之后有一部分。
It was almost exactly a year ago when the Falcon 9 booster
刚刚是说
set
那
to
个
carry
会，
NASA's DART mission
因为会有一部
first
分
took
液氧
flight.
会气化嘛，
On
所以
November
说是会
21st,
加注的同时也会
2020
排出一
at
部分。
9:17 a.m. Pacific time,
所以我们看
Falcon
加注
9
的时候
lifted
总是
off
会有
from
一些排
Vandenberg
气的动
Space
作。
Force Base here in California, carrying the Sentinel-6 Michael Frelich mission for NASA to its targeted orbit.
那么这是上一次在凡登堡进行的一个 NASA 任务，哨兵任务啊。那么是一个海洋观测卫星。
booster recently flew a Starlink mission in May of this year from our Space Launch Complex 40 pad out in Cape Canaveral, Florida, landing back on our drone ship. Just read the instructions in the Atlantic Ocean. Now, today, this booster will make its third flight from the pad, where it all started with the launch of NASA's DART mission. Roughly 2.5 minutes after liftoff today, the Falcon 9 first and second stages will separate, and the second stage will ignite its single Merlin vacuum engine to carry the DART spacecraft to an interplanetary trajectory. The DART spacecraft will separate approximately 56 minutes into flight and spend the next 11 months cruising to its intended destination. Following stage separation, the first stage will make its way back to our autonomous spaceport drone ship called, of course, I Still Love You, which is currently stationed off the coast of California. Now, keep in mind, it can be tricky to maintain the video feed as the booster makes its way back to Earth, but fingers crossed, we'll get some great views as it completes its third trip to space.
这个还是可以期待一下。一个是 Of course I Still Love You 号的通讯信号，一般来说，根据我们看的经验来说，比另外2艘回收船的一个信号要稳定。还有一个就是在西岸这边的通讯状况好像是要比东岸要好一点。所以可以期待一下。
Yeah, you sure can, and that's what we like to see. You know the
所以我们希望可以看到一个相对比较连贯的一集的回收画面，可以期待一下。那么假使都已经露面了，空舱那边的直播还不开吗？还是不开？我看只有 NASA 这边的直播可以看到目前。
There's a live look again at the pad, and now we can see the liquid oxygen venting off the side of the Falcon 9 rocket. Fueling began about 9 minutes ago, and so
这里的排气动作呢，其实就说明了液氧加注已经开始了。
Yeah, absolutely. I mean, that's what you want. You want an uneventful
也可以注意啊，你可以是说是火箭身边缠绕排气的部分呢，其实是从就是它的不是从最底下开始，因为最底下部分呢是它的燃料舱，加注呢是航天级煤油。那么再往上的部分呢才是液氧舱。液氧舱呢，因为它使用的是超低温液氧，所以说这种低温呢会导致火箭表面结上一层毛豆病，然后凝结空气中的水汽，产生这种白气缭绕的情况。
Yeah, and that's because they use densified propellants, which are very, very cold. And so they fuel this close because they don't want it to warm up too much, and you want to keep it down in those really cold cryogenic temperatures prior to liftoff. And SpaceX has gotten very good at that, at fueling this late in the game. They're very efficient at it, and it's just a normal part of the process at this point.
All right, so we're going
它
to
比较贪
continue
心
to
使
keep
用
an
这
ear
种
on things.
超低温
Next
液
thing
氧
we'll
的
be
目的呢
listening
是
for
进一步压
is the
缩
SpaceX
氧化剂的一个
launch
体积
conductor pole
在
at
同样
T-4 minutes. That's
同
the
样
next
的
milestone
体
you
积的火箭里
see
面
on
装
that
进更
progress
多的
bar
氧化剂
on the
来
bottom
提
of
高
your
火箭
screen.
性
So
能。
be listening
这么
in
也
for
导
that.
致问题就是说
But
是
for now, we're going to toss it
因为
back
火
over
箭的
to
保温性
Daryl
能
and
不好，
Kelly.
火箭也不小，空差也非常吝啬，不想装泡沫保温层来增加火箭重量，所以他们选择的策略呢，其实就是思维转换了一下，就是在最后一刻进行燃料加注。所以这是为什么他们在发射前35分钟才开始加注燃料和氧化剂的原因。
Right, well, NASA-funded telescopes are responsible for most of the near-Earth asteroid discoveries, which now number 27,532, according to the Center for Near-Earth Object Studies website.
Okay, well, and that's an up-to-date number.
空舱表示是发射前15分钟开直播。
Well, that's the thing of the subset that are of a larger size that could really do damage that the Earth's atmosphere doesn't protect us from. That larger population, we've probably only found about 40% of those.
Only 40%. Which means there's a lot more out there.
这个也是他们，这个也是他们那个什么这个项目的销售词语啊，就说是对地球有可能产生威胁的小行星，或是近50年内啊，就是可能对地球产生威胁的小行星来说，现在的观测完整度，据他们的统计来说是大于40%。所以他们是以此来宣传，就说是像这种类似的小行星，防御系统和甚至观测项目的一个必要性，确实也是蛮重要的，尤其这种其实特别容易引起一般人的兴趣。
NASA's Raquel Villanueva talked to 2 key people about how FEMA and NASA are working together on this.
While there's currently no threat of an asteroid or comet heading toward Earth,
现在是
there is plenty of work being done to prepare for a potential threat.
当然，刚刚说的是说有可能威胁，就是说像定义的话，就是说是未来50年内，就是说有可能近距离掠过地球的一个小行星。
Leviticus, Lindley, thank you for joining us today.
Glad to be here. Yeah, you're welcome.
但目前来说，就是真正是完全有可能撞击地球的小行星，或者说是有足够威胁的，且会撞击地球的小行星，应该是目前是没有这方面的预测。那潜在的话，就说刚才也说了嘛，观测完整度并不是很完整的。
Then be able to determine when and where that impact might occur, so that we can inform the emergency response community if we don't have enough time to do something about it in space.
FEMA is interagency
and also an all-hazards organization. So planetary defense is just one more thing on our list of hazards that we should be prepared for.
One of the many emergencies.
那么这里还是一个任务意义的一个采访和宣传，这个其实也不必多说，大家应该是明白的。
What is being done to discover and track this?
Well, NASA and the Planetary Defense Coordination Office sponsors.
就他们这个应该是有美国专门有一个办公室，就是所谓 Astronaut Defense Office， 应该是就是专门为了这个问题成立的一个小办公室。那么他们办公室下的任务，这个是其中之一。应该之后还会有一个专门针对，就是说靠近地球小行星的一个观测卫星。好像是明年还不知道后年会发射。
Then an asteroid impact is just like any other natural disaster, and so the emergency response community needs to know when and where and what the effects could be.
这两个那么算是相辅相成吧，因为其实说是我们能够去改变小行星的轨道的能力是很有限的。所以你要做到这一点，有效的去改变轨道的话，你要做到提前发现，那么在尽量远的地方呢，就实现这个撞击，给它足够的时间能进行轨道偏移啊。其实说白了就是说，你撞一下，理想情况其实也就是给它一个几厘米每秒的一个额外速度。所以它开始偏转的时机越早的话，那么就是越可能是离开地球。那就是一般人很喜欢讲的，就是直接拿个核弹去炸，把它炸碎之类的。这个也有问题啊，就是说，如果你去用核武去把一个小星炸碎的话，那问题就是你会带来更多的碎片啊，这些会往哪飞，其实也不好说。所以单纯的用一个动能撞击，其实是相对比较干净的做法。发射前20分钟，这里呢有一个特征的排气现象，这样每次发射前20分钟的时候都会有一个特征的排气，这个是一个正常的现象。两个宇航员，他们有做节目介绍吗？
NASA's DART mission. Okay, yeah, so DART is NASA's first planetary defense test. So we're gonna try to do something we've never done before with the spacecraft.
其实个人本来是对这个理念有点不屑一顾的，因为就是说，像单纯的碰撞这种事情的话，其实数字模拟可以做到大部分的，就单纯的模拟可以做大部分的一个实验设计，对吧？因为它的物理是很简单的，具体想的话，还是会有一点点不确定性，因为主要是你碰撞之后，它会有一些碎片飞出来嘛，就那碎片会带掉一定的动量，所以你是完全计算的，也不能说能计算太精准。所以说到这部分还是有一定小小的不确定性。做一个实验还是可以把模型更加完善一点。个人觉得还是觉得这个光单纯做这个还是相似含量比较低啊。所以说 NASA 呢其实也是借着这次任务，做了很多新设备的展示啊和验证。他们这是一个动量交换的动量守恒的一个演示吧，算是，就扔一个东西嘛。
I've redirected chain successfully.
扔一个包裹，然后把这个宇航员的位置变或者说运动方向变换掉。其实这个任务还是很有想法的，就是说一个是它的成本预算控制的非常严格，是一个小预算的任务，还有一个就是借这么一个平台验证了3-4样新的设备，那包括这里提到的，就说是在国际空间站上已经用上了一个新型的太阳能板。
very end of the space station out on the port side.
那么在这个飞行器上呢，还有一些小的局部改动啊，就说它是有一些小的反射镜啊，那么也是希望能够进一步的增加，或者说是在保证同样功率的情况下减小太阳能板的质量的一些小的新颖的设计。他们也带了一个下一代的新的电推喷塔，然后刚才那个竖起来的就太阳能板竖起来的上的一个小片呢，其实就是它的反射镜啊。是一个像一个小设计吧。反射镜呢，就是希望它收集更多的阳光那么在同样功率下呢，可以希望进一步减少那么太阳能板的整体质量，也是实验性质的东西。
might react a little differently from astronaut Shane because in addition to being impacted by something, there might be material thrown off from the surface that will affect that motion too. So it'll be a little different, but again,
为什么说这个不是单纯的用物理计算就能计算出来的部分呢？就是说不光是一个赋予它一个额外的动量，对吧？主要是因为会有碎片飞出来，这个碎片能带走多大动量，这个其实是不大好计算的。那么就说这里有一个实际的数据可以补充一下模型。
But first, Sampson has the latest from the DART spacecraft team as they prepare for launch.
那么像这次的话，其实还是希望是有相应的具体观测的。我记得应该是这次飞行器上应该是带了2颗子的那个立方卫星，应该是意大利制造的。那么应该是会在撞击前10几分钟放出啊，然后应该是做一个一次性的观测。那么之后应该是欧航局还会做一个跟踪的任务，就说是来进一步研究它撞击之后小行星的表面状况。那个就要再晚个1-2年。
Instances where a problem arises, so say a ground-based antenna goes down.
Now, as many of you may know, on your screen is a live view of our Falcon 9 launch vehicle. Our two-stage liquid-fueled launch vehicle is in position at Space Launch Complex 4 East at Vandenberg Base. Today marks the 26th mission for SpaceX this year and 128th flight of a Falcon 9 vehicle overall. This is SpaceX's first flight-proven launch for NASA's Launch Services Program. This first-stage booster supported Sentinel-6A around the same time last November and took its second flight on a Starlink mission in May of this year.
那这边 NASA 和空差是分开直播的吗？很有意思。不好意思，没有想到它这边原是分开的。那么这是空差今年第26次发射任务。
is to accelerate the vehicle all the way to the edge of space with the help of 9 Merlin engines. It will then drop off the second stage carrying today's payload, which is NASA's DART or Double Asteroid Redirection Test
那么接着可以再介绍火箭，那么底下的3分之2呢是火箭的1级，那作用是把火箭整体推出大气的范围，之后呢是由2级继续把目标把载荷呢加速到目标轨道上，那么这次算是一个逃逸轨道，那么1级呢会在驳船上回收，那么刚才看的回收船 Of course SW 号的一个画面。那么中间的黑色环呢就是1、2级的连接环，那么以下呢就是1级，往上呢就是2级和整流罩。那么黑色连接环内部呢是刚好装有了一个，也就是2级引擎，一个真空优化模拟引擎的位置。那么2级分离之后呢，2级还是会持续加速相当长的一段时间，把火箭推到目标轨道。那么这次2级应该会点火2次啊。往上只有突出的部分呢，就是这次的整流罩。那么整流罩作用就相当于汽车挡风玻璃啊。那么在火箭高速在大气中行驶飞行的时候，保护载荷和火箭的健身。那么这2枚整流罩呢都是全新的，这次。 那么这次呢，整个站会进行一个海捞回收。在东岸西岸负责的回收船应该是 NRC Quest。应该是一个前不久签约的一个船只，也是由其他公司负责运营的，不是空船直接运行的，但是应该是空船租的。那这一切的总数来自一个这些状态的播报。
We received the final countdown briefing from the SpaceX launch director, and we began the final checks of the launch vehicle and the ground system. Final checkout of the flight termination system was performed at T-minus 1 hour 45 minutes. Now, most recently, we completed the polls to proceed with propellant load and launch. Propellant loading is ongoing. We started it on time at T-minus 35 minutes. Now, Falcon 9 is a bipropellant vehicle, meaning it uses two propellants, a fuel and an oxidizer. For Falcon 9, a fuel is a refined form of kerosene known as RP1. Now, to burn the fuel, we need a source of oxygen, which we call the oxidizer. Most burning on Earth uses oxygen, which makes up about 21% of the air you breathe. However, in space, there is no atmosphere to provide oxygen or other oxygen-bearing molecules.
因为它要在设定在太空中使用，那么所以说呢是不能指望大气来提供一个氧化剂，它一般都是会自带氧化剂的。那么空舱呢使用超低温液氧是一个比较贪心的做法，在把氧气液化之后呢，还进一步降温，以压缩它的体积。这是为什么空舱需要在最后一刻才进行燃料加注？那么因为火箭保护性能不好，所以说是晚一点加注，可以防止氧化剂吸热之后沸腾。但还是会吸收一部分热量，所以说它整个加注是一个动态加注，边加注呢还会边排出一部分气体。这时我们时不时会看到发射塔或者是火箭周边上呢冒出一股一股的白气的原因。那火箭周身残留的白气主要是因为超低温阴阳导致火箭表面结冰的缘故。那么除了氧化剂和燃料之外呢，还有加热气体氦气，那么作用呢是把氧化剂和燃料最初推到预燃烧室里面。那么此外呢还有点火器，应该是 T-tab。待会点火的时候，像晚上的话应该比较容易看到，会有一个特征的绿光一闪，在点火的时候可以看一下。那么一级的作用也是把往上二级核载荷船推出大气，并且进入一个最初的一个抛射轨道。那么二级呢会继续把载荷加入到最终的载荷需要放出的轨道。那么这次应该是一个2次点火，那么第一次点火应该会持续到发射后8分06秒，然后之后是宕机，整个火箭等载荷呢运送到最初轨道的原地点之后呢，进行第2次点火，也就是在28分钟半的时候再进行一个额外的1分钟点火，加设一个高投入的逃逸轨道。
So with that, the launch vehicle, the spacecraft, the weather, and the range are all good to go for a 10:21 p.m. Pacific time liftoff from Space Launch Complex 4 East.
太平洋时间10点21分进行一个起飞。
Kick off a roughly 11-month journey for the DART payload. The DART spacecraft will separate right around 56 minutes into flight, and from there it will spend the next 11 months cruising to its intended destination, intercepting the binary asteroid system between late September and early October of 2022. DART's target asteroid is the size of
那么这是空船的今年的第26次发射，也是意味着这次发射之后呢，应该是会和去年的发射记录追平啊。其实还是比预想的少了很多，主要是星链耽搁的比较久。
This will enable scientists to observe and measure the change in momentum of the Dimorphos asteroid.
它这次的目标呢是一个小行星双星系统，还是作为那个小行星防御系统的防御的一个策略手段之一的演示。每一概念上来讲的话，就说是我们需要有某种手段来防御将来有可能撞到地球的小行星。那么这里只是通过一个动能冲击来改变其轨道的一个实验啊。那么它选取的是一个双星系统，来撞击出比较小的那一颗。
but not enough to destroy the asteroid, eject it from its orbit around that larger
这也
asteroid,
是比较聪
or
明的一个做法，
noticeably
因为
change
是
the
选取了一
pair's
个小行星
orbit
双星
about
系
the
统，那
sun.
么它的相互绕
Now,
行
the
速度比
second
较慢。
objective is to change
那
the
所以说你
binary
其实
orbital
即使用
period
这
of
样的一个小的飞
Dimorphos.
行器去撞的话，还是
Now,
有
the
可能
orbital period
能够
is the
产生大
time
约
it takes the
1%不
smaller
到的一个
asteroid
速
to
度变
circle
化。
the larger
那么
asteroid.
会
You
使它
can see
的
here
互相
in the
绕行的轨道
graphic.
稍微变大一点，
Currently,
那么的话也
Dimorphos is in that original orbit.
变小一点。
Scientists estimate the
那么以此呢，
collision
你可以
will
缩短
shorten
它
the
的一个
smaller
绕行周
asteroid's
期。
orbital period by several minutes, placing it into that new blue
才
orbit.
说15分钟，其实就说应该按照预计的话，是可以把它的11.8小时的一个绕行周期大概变快大概70多秒吧，这样的话就比较容易观测。因为它这次的观测是作为验证实验，不光是撞，更重要一点是你撞之后的影响能够被明显的观测到。这是为什么是选这么一个双星系统？一个是它速度本来比较小，所以你的变化比例相对比较高；还有一个是你可以通过它的互相绕行速度的周期来间接的来验证它的轨道变化。因为长度和速度变化这两个都是非常难观测的，但是绕行周期这个时间的测量是相对非常容易的，所以这是一个比较聪明的一个实验设计。那么这次目标呢是双星系统一个比较大的呢可能是叫 Didymos， 还有一个是小的呢可应该是叫 Dimorphos。那么这两个系统呢是应该是1.02乘以2.2多日地距离的一个椭圆轨道啊，它应该算是离地球比较近的一个小行星系统，好像是按照某一个尺寸标准来说是未来几年当中排行第4离地球近的一个掠过地球的一个小行星系统。虽然不会对地球产生真正意义上的威胁，但是因为它会离地球比较近，所以说是它的观测也会比较容易。那我刚才提到，就说这次这个的飞行器上负责2颗小型的观测立方体，那么应该是在撞击前10几分钟放出，那么应该是在撞击前3分钟左右的时候会掠过那个 Dimorphos， 做一个好的观测点。
NASA is crashing a spacecraft into an asteroid.
What? You think science fiction, but this is real. Never in my life would I have thought I would take a couple hundred
之前也有就说是可能是欧航局做的撞击小行星的一个实验吧，当时那个叫什么忘了。当时那次撞击彗星，当时那次的实验意义主要是想研究彗星的成分嘛，通过撞出一些碎片，然后分析光谱来分析那个彗星表面的一个岩层成分。那这次呢是真正意义上它的目标就是去改变它的轨道，并且去观测它的结果的一个演示实验。
DART is the Double Asteroid Redirection Test.
It's just a spacecraft that is going to go and smack an asteroid.
DART 它的全称呢是Double Asteroid Redirection Test， 可以译为是双星重定向实验，双小行星重定向实验，可以这样翻译。理想情况下，就说是在未来的情况下，如果有小行星可能会在未来撞击地球的，那么就提早发一颗小飞行器撞击它，使它的那个飞行轨迹呢能够有所改变，以掠过地球而不是撞击地球。这其实是一个相对比较低价的、低预算的一个验证实验，所以它的质量其实说白了还是比较小的，670公斤的起飞质量。如果真要做的话，应该还会做得更大一点。那么这次呢，应该说是做得更小啊，所以选这个双系统呢也是便于观测。
Our spacecraft becomes autonomous, and then that's where everything gets really exciting. You actually are seeing impact. We're super excited and nervous as well.
I feel really honored and humbled to be working in an area of science that has such a broader impact.
小行星防御这个事情，说实话，你说起这个话题就会打很多人的鸡血，他们这里也表现得很兴奋。个人觉得，就是说，本来你去想的话，它其实主要来说是一个动量交换嘛，其实是个比较单纯的物理过程。你仔细去想的话，撞击过程中，因为它不光是单纯的赋予额外动量，因为可能会炸出一些碎片嘛。
On your screen, you can see the large structure next to Falcon 9.
现在是支架塔向后撤回的时候。
The clamp arms have opened up, and you can see that the
你看到，就是本来上部固定火箭的一个机械臂打开之后呢，那么支架塔向后撤回了一个角度，算是进入了一个发射预备姿态。那么还有一些软管是快速脱落软管的，大会是在发射起飞的时候才会脱落。现在呢，一级的燃料已经加注完，一级、二级的燃料都已经加注完毕。那么一级液氧应该是快要加注完毕，二级的液氧呢还会再持续加注大约1分钟左右。记得梵登堡这个发射台，它的支架塔最后起飞的时候会打开的比较厉害，可能会想导回大概60度左右。那刚刚播报的是一级的燃料液氧加注完毕。
The first stage LOX loading being completed. Second stage will complete around T-2 minutes. And Falcon 9 and Dart teams continue to track no issues for launch. Weather is still looking great, as John mentioned.
液氧完全加注完毕之后，支架塔还会把多余的液氧排掉，到时候会看到一个比较特征的一个大量排气动作。
Second stage coming up next around T-2 minutes. We should hear LOX loading completing for that stage.
我忘记我之前在讲什么了。反正我应该还是有充分的时间去聊这个任务的，因为这是整个过程有50多分钟、55分钟的时候才会有载荷的放出。
Coming up on T-2 minutes, waiting for the call out that LOX load is in closeout.
那应该是2级的液氧也快加注完毕了，那么待会会播报2级液氧口的加注关闭。之后呢，我就看到支架塔侧面进行了一个特征排气。看的人好少啊，这11个。好，播报是2级的液氧加注完毕。
This completes loading of the over 1.1 million pounds propellants on the Falcon 9.
支架塔的右边喷出一团白气呢，这就是它把多余液氧排掉之后引起的空气中的水汽凝结产生这一大团白气。
And that creates the white cloud that you see around the strongback. Pressure from the ultra-cold liquid oxygen line is being vented, and that causes moisture in the California night air to condense.
像梵登堡就是西岸这边的，常年就是空气中水汽很高，所以像喷气之后，它形成这种白雾啊，都比较厉害。现在是发射前1分钟，火箭进入了 Startup Mode， 这意味呢是火箭的电脑系统呢完全接管了控制权，并且呢已经通过了最初的一个电脑系统自动检查。接下来呢就等一下发射前45秒的发射指挥的最终放行确认。可以听一下它的播报。那么这个发射指挥给出了 Go for Launch 的放行确认，那么今年是能飞。把音量稍微调大一点点，我待会儿记得调回来，上次忘了调回来。我听一下起飞的音效。
15, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. Now the DART mission on the way for humanity's first ever planetary defense test mission. Vehicles pitching downrange.
这个音质有点渣呀。我跟你们说，这次真的不是我的瓜。之前有几次是因为我的开了那个降噪，这次听上去声音这么糟，是音源本身就有问题啊。 我听到声音也很奇怪。
Stage 1 chamber pressure is nominal.
是不是空舱那边也开了降噪？就是直播的时候。
+33 seconds, SpaceX launch engineers seeing a nominal conditions on Falcon 9 as we begin the trip to space carrying the DART spacecraft.
好像还是有点晕是吧？
engines
还
about
是有
to
点怪
begin
怪的。
throttling down.
那么左下呢，我们可以看到有这次的高度和速度表，左边呢是速度表，右边呢是靠右呢是高度显示，一个是每公里每小时的和公里2个单位。那么很快呢会进入火箭的超音速，随后到来呢就是火箭的 Max Q， 也就是最大的空气动压点。
Max Q。
好，通过了最大动压点，好快啊！
We're through the period of maximum dynamic pressure. The Maryland 1D engines
这
have
次
throttled
的
back up
Max
to
Q 来的
full
好快，
power
比
out
平
of
常
the
快一
throttle
点，因
bucket.
为是大
From
概
here
应该是
on,
载
even
荷
though
比
the
较轻的缘
velocity
故
is
啊。
even though the velocity is rapidly increasing, the atmospheric density is decreasing, and
这
so
次
the
是1
loads
公
are
斤不到的载
decreasing
荷，
now
这
on the
种
Falcon
轻量级的载
9.
荷是很少在019号上看到的。
Everything continues to look good with the stage 1 trajectory.
那么最大空气动压呢，主要是因为火箭上升的过程中速度越来越快，同时大气密度越来越低，一个和那个空气阻力正相关，一个负相关，所以在空中达到最大点呢就叫 Max Q。那么通过 Max Q 之后呢，火箭的大气环境呢是越来越稀薄，那么大气环境压强也越来越低，所以我们看到火箭的尾焰会逐渐因为外部压强的变弱呢，会出现一个明显的扩散现象。 看尾焰看上去形状上看去越来越大了，随着这种扩散呢，也会导致尾焰的温度越来越低。所以可以看到火焰的，从晚上看一直是很明亮，但是到熄火前的时候，逐渐看到火焰好像是有点变淡了，对吧？那这是因为火箭那个尾焰扩散之后尾焰温度变低所导致的一个现象。那么很快是在2分30多秒，我们应该会迎来火箭的1级熄火。 我们从地面上看一下熄火，晚上的熄火是很明显的。好，熄火。我们确认到熄火，那么随后呢，1、2级会分离，2级呢也会随后点火。那么现在我们看到画面当中，左面呢是1级看向2级的画面，右边呢是2级外部的画面啊，2级要点火了，又是绿光一闪，是点火点火机 T-type 的一个特征颜色。 发射也可以看到，那么2级引擎外部凸出的一个橡胶环呢，是一个固定用的橡胶环啊，它起到呢是在1、2级固定2级外壳和进一步减震的一个作用。2级点火之后呢，它就会脱落，也不用太担心，像2级那种橡胶环，它的载入时间一般来说就1到2个礼拜，是很快的。好，现在看到是整流罩内部画面，整流罩即将分离，整流罩分离。 那露出这载荷，隐约的其实也可以看到，就整个罩内部是非常空的，虽然就这个镜头角度可能不是特别直观。那整个整流罩呢是3米高多一点，而这次的载荷呢只有2米多高。好，刚播报是2级的方向良好。其实也是一个有趣的故事啊，之前有提就说是，这次载荷其实质量很小，大小也比较小，就是670公斤的起飞质量，但是却用了019号。 那主要是，主要这个载荷开始设计的时候就不是专门一个是作为主要任务设计的，而是希望是搭其他去往近地轨道的一个同步轨道的一个发射作为次力载荷来使用的，这样设计。但是没想到空差竞标呢，就是不光以低价，而且是表示我们可以包车给你送啊，所以有了这么一个比较奇怪，大整流罩小火箭小载荷的一个状态。 请注意的话，右边是对，现在1、2级分离之后呢，右边是会单独给出2级的速度高度表，左边呢是1级的高度和速度。这里可以注意，和一般的发射相比的话，它现在这个时间点的速度是偏高的，也是因为载荷呢是比较轻的缘故。我现在主要来看一下1级的速度高度表。 那么1级在1、2级分离之后呢，其实是还是会随着惯性啊，一个抛物线还是会继续往上升一段时间。那么现在呢，应该是刚刚通过它最高点开始重新掉回来了。那么待会应该是在6分半多一点的时候，会重新达到大气的上部比较致密的地方。那个时候呢，会进行一个火箭的再入点火，以初步的去掉火箭的1级的大部分速度啊，大概40%度的一个下降速度，来防止火箭待会在下降过程中呢过快而过热。 那么除了载入点火之后，那么载入点火会持续大约20秒左右啊。那么除了载入点火之后，当然还有就是在最后着陆阶段的一个反推点火，把火箭的垂直速度降到0，然后能够稳稳的降到波船上。又是播报2级的方向良好。
The first stage booster again supported a Starlink mission earlier this year and the Sentinel-6A mission in November of 2020. Now, both fairing halves for this mission are brand new and will be recovered for the first time on a recovery vessel NRC Quest.
这是它的第3次使用，这也是现役火箭当中应该是最新的一枚1级啊。
We are just about 30 seconds away from that entry burn on first stage.
说错了，你可以改正我一下。那么现在是6分20秒左右，那么1级的高度已经下降到80多公里啊，大概应该是会到60-70公里左右会进行载入点火，应该是70多公里，快了，还有10秒左右是1级的载入点火。镜头要切了啊，切了。那么左边画面就是1级的画面，外部画面。好，快了。好，1级载入点火开，好，载入点火开了。仔细看的话，其实还可以注意到，开始2秒的点火和后续的点火其实是有点不一样的，这是因为它载入点火呢会点燃3个梅林引擎，先点燃中央的一个引擎，然后再点燃2边侧面的2个，所以火焰的形状其实有一个小小的变化。仔细看的话，那么应该是20秒的载入点火，应该是快结束了。好像这次比20秒多一点啊，应该是25秒、23秒不到的样子，可能是因为这次的1级的速度相对快一点。那么现在是快准备2级熄火了。可以注意一下，1级现在高度已经下降到20公里以下，那么应该是会到还1公里多的时候是载入点火，不是着陆点火开始啊。那么应该是还有50多秒的时候就会有1级的着陆点火开始。因为这次的发射呢，我还是希望能看到一个比较连贯的1级回收画面。对 ，Of course, I still love you 还是可以抱有一点期待的。好，看到是2级的熄火。那么现在是等一下1级的回收，应该是快开始着陆点火了。好吧，应该是3公里、2点多个公里的时候开始载入点火，着陆点火吗？
That's what we were waiting for.
好，着陆点火开始。
So we got SECO 1 on second stage. We got a confirmation of good orbit, and the landing burn has begun on first stage. And now we have a live view of first stage making its way to, of course, I Still Love You.
所以降得蛮不错，着陆腿打开，卡了，还是卡了，还是卡了呀。
And we had some incredible views. Now we're just waiting for some confirmation of that first stage landing here in a second. As we have a live view of second stage currently with the engine cut off as it's coasting towards its targeted orbit.
那么接下来会有一个比较长的，相对还是比较长的20多分钟的2级宕机时间啊。 那么之后会有一个1分钟的2级再次点火。
You have just witnessed Falcon 9's 26th flight for this year. And we will confirm once we have that confirmation for that first stage landing. So now at this time, our mission isn't over just yet. The second stage is now embarking on its first coast phase. Coasting in this orbit will last about 20 minutes, and we will light that MVAC engine for a second time shortly after T plus 28 minutes and 38 seconds. So we'll see you back here at T plus 28 minutes.
也等一下不看1级吗？他溜了呀。主播溜了，哎呀，我刚才又忘了把音量给切回来了。那待会刚才可能原视频音量在我讲话的时候稍微偏响了一点。那现在是大概是 接近20分钟不到的宕机时间吧。我觉得它还是会给一下1级的画面的，我们等等看吧。虽然主播现在溜了，对吧？他拿到1级画面的时候，可能还是会给一下的。应该没出什么幺蛾子吧？看看推特上有什么消息。没看到什么消息，应该不会出什么幺蛾子，我觉得。1级的回收应该是已经比较稳了。那除此以外，其实上次我们有发，就说是上一次发射可以认为是空差的第100次连续发射成功嘛。当然，其实可能还是稍稍有一点点争议，就是你能不能把那个就是为了载人的空中逃逸演示实验算作一次成功的发射任务。那次应该可以算吧，勉强来说，但可能有点争议啊。如果那次不算的话，那么这次就会是连续100次发射成功。当然，就是你这个两者的区别，就看你算不算那次逃逸实验作为一次成功的发射任务。我这里额外提一下，还是没有1级的画面吗？好，那我刚刚有一个比较明确的播报，就是1级的着陆成功确认了。为什么隔了这么长时间？刚刚有那个播报了，那么画面应该看看会不会给。1级的消息已经有了，就是刚才有一个语音播报，说是1级的着陆确认了，画面还没有看到。应该拉小一点吧。画面没有。空差这边好像就宕机了。NASA 那边不知道在聊点什么，要不要切回 NASA 去看一下？但是没有想到这边空差是做了一个相对比较独立的直播啊。我本来以为是会还是像以前一样，就是 NASA 和空差都用一样的源。其实这样形式还是可能还是比较好吧，因为空差这边是至少画面比较好嘛。我在油管上最多给到1440p，而 NASA 那边只有720p 的直播。看一下 NASA 那边在放什么。因为空差那边在等吧，所以就是宕机，他们应该是会。应该是28分钟半的时候是2级的2次点火。你这边可以放一放他们这边的。
In case there was an asteroid coming towards Earth and you're there, you can actually stop it. I mean, this is kind of fantastic.
NASA is crashing a spacecraft into an asteroid.
What? You think science fiction, but this is real. Never in my life I would take a couple $100 million spacecraft and crash it into an asteroid. My name is Michelle Chen.
I'm Lena Adams. My name is Kelly Fast.
我先把 NASA 这边的画面先挂着，我也去稍微上厕所喝倒杯水。
My job was primarily to make sure that all the systems on the spacecraft work together.
The DART mission is NASA's first test of a planetary defense technique called kinetic impactor.
DART is the Double Asteroid Redirection Test.
It's just a spacecraft that is going to go and smack an asteroid.
The moonless Didymos, which orbits the asteroid Didymos.
And see if we can change its trajectory just a little bit.
In order to show that we can deflect incoming asteroids if we need to.
DART will only be changing the period of the orbit of Dimorphos by a tiny amount.
But in space, just a little bit is just enough to make an asteroid actually miss us.
In the event that an asteroid is discovered well ahead of time before it might impact Earth.
Behind me, you see the spacecraft.
It's really cool to see it coming together in real life.
It is fantastic to see it in real life.
To see it turn from ideas into real pieces that are going to go into space.
The solar arrays will actually roll out to 28 feet in length.
Once the solar arrays are deployed, it's going to be the size of a school bus. As the solar array opens out, it's going to swing out in this direction. The asteroid's only 2 football fields in size.
We're flying at over 6 kilometers a second.
30 days out, we see 1 pixel on our field of view.
You can see Didymos and Dimorphos as 1 point of light.
About 4 hours out, our spacecraft becomes autonomous.
And then that's where everything gets really exciting.
You actually are seeing impact.
We're super excited and nervous as well.
I feel really honored and humbled to be working in an area of science that has such a broader impact, figuratively and literally.
So dark. The dinosaurs are made completely extinct by an asteroid impact so many years ago. Here we are, we can actually do something about it. I think this is just wonderful.
And as was mentioned in there, this is the first planetary defense mission. And this is your office we're talking about, Kelly. So for the audience out there that doesn't understand or hasn't heard of this before, what is the Planetary Defense Coordination Office? What do you do?
Well, right. Well, NASA's actually been working on near-Earth asteroid research since 1998, so this has been going on a long time. But in 2016, it was really formalized more in the creation of this Planetary Defense Coordination Office, which is in the Planetary Science Division at NASA headquarters. And it takes that legacy near-Earth object observations program, all the, the finding them part of the program, and then combines that with these other activities like DART, like the development of the Near-Earth Object Surveyor Space Telescope, like our interagency collaborations like we saw with FEMA there, our international collaborations, and formalizing all of that and leading the Planetary Defense Coordination Office. Lindley Johnson, we say he's got the coolest title in the solar system as NASA's Planetary Defense Officer.
All right, and he sure does. I enjoy listening to him in that interview earlier. Now, throughout the show, we will be taking the most popular questions NASA gets about asteroids and posing them to experts like Kelly. This next question is for NASA expert Marina Brozovic. When was the last time an asteroid hit Earth?
Well, the answer depends on whether you're asking about small or large impacts, because Earth gets hit all the time. But luckily for us, the vast majority of these impactors are small, and they just burn in the atmosphere. The most significant fireball event in over 100 years occurred over Russia in 2013. We actually got hit by an asteroid that was the size of a small building, and that one disintegrated about 20 kilometers above the city of Chelyabinsk. And it deposited a fair number of meteorites on the ground. And I happen to have a piece of that Chelyabinsk impactor right here in my hand. But what about big impacts? The ones that leave craters tens of kilometers wide and cause huge amount of devastation. We have to go far back in time for such an event. And those old craters are not easy to spot, because by now they're heavily eroded, they're filled with sediments, or they can be at the bottom of the ocean. But to keep the long story short, small impacts, they happen all the time, especially given that about 15,000 tons of space dust hit Earth every year. And large impacts are rare, and we're talking millions of years rare. So when was the last time an asteroid hit Earth? Probably today, but the odds are it was very small and just burned in the atmosphere.
The binary asteroid system DART is taking aim at was chosen for many reasons. Let's join Raquel Villanueva with a special guest to explain that. But first, Raquel, you saw the launch in person live. What was that like?
Ooh, it was chilly with lots of excitement and lots of cheers, lots of fun. And I am here with DART program scientist Tom Statler to talk about the Double Asteroid mission. Like, what did you think of launch, Tom?
Oh, Raquel, it was a beautiful, beautiful launch and tremendously exciting.
Now, can you tell me why the asteroid was chosen?
Oh, well, a binary asteroid system and the Didymos binary asteroid system is the perfect natural laboratory for the Double Asteroid Redirection Test. For one thing, the larger asteroid makes sure that the smaller asteroid is held in orbit around it, so there's absolutely nothing that we can do that would make this asteroid a danger to the Earth. But more important, it's about the measurement. We need to be able to measure how efficiently DART deflects the asteroid. And we're using that binary orbit, the little asteroid around the big one, to do that.
说的也有道理。就是你这样想的话，就是如果你把成功发射定义为火箭完成它应完成任务，那么应该可以算，因为当时它就是把这个火箭把火箭上升到 max Q 的高度，然后在那个时候让龙飞船逃逸嘛。就这个角度来讲，它应该算是完成了任务的。它没有进轨道，那可能说可以哔哩哔哩一些东西，但应该是把它算成一次成功发射，问题应该是不大的。
500 kilograms, which Andy Rivkin, one of the investigation team leads, said the other day is about the mass of a small cow, which is, I guess, true. And it's going to be impacting the asteroid at a speed of about 15,000 miles an hour. So at that speed, it covers the last 4 miles to impact in 1 second.
对，其实，在 B 站上有人问我，就是为什么不用个什么弹头之类，就是不是核弹头，一般的弹头，搞点爆炸物进去。其实它道理也是比较简单，就是说，就是它的动能，就是它撞击的相对速度是大约是6.6公里每小时，每秒。这其实放轨道没什么了不起，但其实仔细去想，这个速度已经非常之变态了。比如你想是，你可以想就是速度的两次方的关系动能的话，那你可以想一般600，你去想象一个600公里每小时的一个车祸，这个是6.6公里每秒，那么它是那种一般车，等一下是，如果车祸我们一般想的是100公里每小时的车祸，那换算过来的话应该是30米每秒左右的一个速度啊。那么这个是一般车祸速度的多少倍？2000多倍，那么它的动能应该是大概400多万倍啊，400万、500万倍的左右一个动能，和一般车祸相比的话，质量呢也算是一个好几辆大货车的一个质量，没有，就一个一般小型车辆的一个质量不到。我想说的观点就是，这个速度下，它的动能是非常变态的。其实这时候再加一点化学能，就是加点炸药之类，其实是可以几乎忽略不计的，没什么意思啊。你还不如多用这个质量弄点有意义的设备。所以这是一个简单的回答口能的一个问题。但如果你装核弹头呢，当然是另外一回事。但是一般的炸弹就是爆炸物，其实是没有什么意义的，因为它附加的能量其实是非常少。
And so what I'm going to do is I'm going to move it out to where the moon would be if it were this size.
Oh, okay.
So here we go, probably about 25 feet, which I paced out earlier. And so if the Earth were the size of a basketball, then the moon would be out here. And so if an asteroid were passing like at 10 times the distance from the Earth to the moon, you know, it would be 10 times out that way.
Right, even probably past the building.
But on a cosmic scale, not that far. You still want to keep an eye on asteroids that could come this close. But as asteroids pass closer to the Earth, again, they're not impacting. As we get to maybe this distance, this is about like the distance of the weather satellites. That's really starting to get close. We don't want to get that close.
What do you have to show?
23分钟，还有5分钟左右。
This type of a scale, an asteroid might be about, in fact, this is too big. This pebble is even too big to represent even the asteroid that took out the dinosaurs.
Really?
Yeah, it would probably be smaller than a grain of salt, but we wouldn't be able to see it very well here.
So is this a close approach?
Yeah, we would call that a close approach, but it's not an impact, and so we're good.
看看有没有一级的消息啊？一级刚才有一个有一个语音播报说是一级会受确认了，画面好像没有看到，推特上也没有看到，可能待会直播从一开始就会切一下。
And that's why you get craters on surfaces when they impact. Our atmosphere does a good job of protecting us, disrupting asteroids on the way in, but if they're large enough, then they can reach the surface and do even more damage, and so that's why you want to find them early. Then you could do something like the DART mission, where you could deflect that asteroid just a small amount, and then it would miss the Earth as you spun the solar system into the future.
Right. Well, can you take this little asteroid and go out there past the moon?
Sure.
Because that just makes us feel better. Now it's way out.
Keep it where it should be out here.
I enjoyed that. That was fun.
That was a lot of fun. I can't believe you found a basketball that looked like the Earth. That was perfect.
Specifically for this demonstration. Great job, Kelly. Most scientific spacecraft have lots of instruments on board, but for DART, there's only one. It's the camera on the front, and it's called Draco, or Didymos Reconnaissance and Asteroid Camera for Operational Navigation.
这也是可以提一下，这个省的误解。他们在介绍那个 DART 上面的一个唯一观测设备，就是它前端的一个摄像头。那么它其实是承担了记录，同时又是一个导航的作用，就具体最后1分钟的导航作用。它这个摄像头这个或者说综合定位仪的名字，简称 Draco， 正好跟那个龙飞船上的那个引擎的名字重名了。但是它全程展开的是完全不一样的，还蛮烦的一个名字。我感觉现在的 NASA 包括好吧，整个天文界都是，他去取名的时候都非常鸡贼啊，就是都故意会把缩写取那些名字，以至于这个缩写能够变成一些比较奇怪的东西。
Can you tell us what is going to happen with Draco?
包括 DART 我觉得也是有意而为的。
So Draco is the eyes of the spacecraft. The images Draco takes provide the data needed to guide the spacecraft.
他们介绍 Draco 的就是那个前端的探测器，主要是摄像头，就包括摄像头中的整一个定位系统。我感觉就先听到这里，我们把那视频停一下吧。我们去看那个空舱那边。那边先不看，我们等一下空舱这边嘛，因为是不切过来有点早，可能是要切早了一点，还有2分钟左右是2级的再次点火。陈水这边说的是什么意思？美国的缩写是反向缩写，啥意思？USSU 不明白这是什么意思？你现在看一下，就是我现在就可以提前缩小，它这边的速度现在是27000，然后高度259，耶，这个是在更新的吗？哦，是在更新的。27000、290，那么其实妥率不是很高，它的现在初步轨道其实应该是比较接近圆形的。27000在这个能够转化的话，应该就是远地点可能就300公里这个样子吧，大概啊，我凭经验估算，但不是很准，估计是一个可能是个190乘290的一个轨道吧，估计。猜测，我瞎说的，不要听我。这个数字不准，反正我就是大概估计一下，误差可能50%左右的是有可能。哦，有了！一看一级画面，很好，我们总算看到了1级的在波川上的画面，不是很确定是不是在正中啊，左右看好像是在比较接近正中，但好像有点靠近镜头。为什么这么糊啊？镜头质量真是渣到要死。还在排气吗？那么应该是1级的一个燃料舱的泄压。Anyway， 我们确认了1级的健康回收。然后把加斯卡声音稍微调大一点。现在轨道方向是良好的，现在反正就是2级的2次点火，1分钟左右开始了。你可以看一下下面的速度增加，1分钟会加到多少？我也不是很确定。那么应该是2级在比较接近还是有太阳照射啊，所以看上去你看，这个角度看好像已经缺了一小段一样，主要是因为下面是被阳光照到，所以特别亮。哎，刚说多少速度？这次呢是要加1到，因为它是做一个深空探测嘛，所以速度应该会是加到比较高的，加到基本上是它足以逃逸地球引力进入一个抛物线运动的一个速度啊。
Index shutdown。
好，结束了，是4万不到的一个速度。OK， 那这次的那么现在解释就是像 Dart 这个任务是，我不是确定Dart 这边确实说是不是真有其实。就是他先选了那个 Dart 这个词，然后再一个去凑字母去想它的全称嘛，我不是很确定啊。那我知道就是天文的取名，应该是前2年，应该一直有人在做这种软件，就是说智能取名软件，就是你把你想要的一些关键词输到框里面去，然后它自己去检索排列组合，然后试图选择出一些缩写，可以凑出有意义的一些名称。是有这种小程序的，有很多人反正天文这方面我知道是有这个小工具的，像我本人没有用过，但大概2、3年前可能读到过这方面的论文啊，在宣传他们的取名工具。然后确实，反正就过去几年间，很明显的感觉到，就是它取名就越来越鸡贼了，就是缩写基本上都是有意思。像 Dart 这种应该可能也是类似的过程吧，就是他在考虑它的名称的时候，基本上是考虑了它的缩写会是什么样子的。像天文里面的一个最有名的工具包，就是从图片当中去提取点信息的一个工具包，叫 Source Extractor 嘛，全称叫。你猜它的缩写是什么？它全称是那个 Source Extractor。然后它就，第一个单词就保留了一个 s， 然后后面的 extractor 你就完整的保留了下来，然后就组成了一个非常鸡贼的，反正有意思，大家可以去写一下。就顺便一提啊，偏题。那么接下来的话，应该是又是一段当机时间，载荷的放出是55分钟啊。接下来这段时间应该就没有什么太多的有意思的信息了，可能，那就干脆的等一下吧。我还是把 NASA 那边切回来吧。随便看看 NASA 那边讲点什么。对，就这样吧。等55分钟切回来的话，它的高度应该就很比较离谱了。那到时再看吧。我看 NASA 这边的直播吧。空船那边我把音量调到最小吧，还是稍微留一下，省得错过什么。
Period of several hours, first or second day in the opportunity. We decided that it was more efficient and a better use of the limited resources that we all have to do these kinds of missions, to focus on having the best launch trajectory for each day. And if for whatever reason we weren't able to launch that day, we've got another day right behind it.
And why did you guys ultimately decide to launch from the central coast of California and not here in Florida?
Great question. Typically, for a lot of our interplanetary missions, the most important thing is to get as much energy out of the launch vehicle, and that's no different for Dart. However, usually the best way to do that is to launch as close to the equator and on an easterly trajectory. So Kennedy Space Center or Cape Canaveral Space Force Station are the ideal locations for that. As it turns out, though, this particular outbound trajectory requires that outbound ground track to be more in a north-south direction. And so we're going to launch from the west coast of California and fly out on basically a southerly trajectory. And that is a much better way to launch to avoid overflights of populated land masses.
Yeah, absolutely. And where will you be and what will you be doing during the launch?
So I'll actually be here at Kennedy Space Center. Typically, pre-COVID,
这个解释半懂不懂啊，听那个，不是特别具体。他就说，我刚才问一个比较好的问题，就是为什么要用那个在加州发射，而不是在那个而不是在肯尼迪太空中心发射？他的问题说，解释是说，他这个任务的轨道需求，要比较靠南端的一些定位，这是一个作为发射的一个需求啊。那么如果要给好的别的南端的一个地面遥测的话，那么在加州更为理想。
Here's a message now from Administrator Bill Nelson about NASA's leadership in this global effort.
At NASA, we are always looking upward.
keeping an eye on the sky for potential hazards and exploring asteroids to help us unlock the secrets of the formation of not only our solar system but the universe.
官场没什么意思，宣传。给大家看一下，就是
Double Asteroid Redirection Test. It's known as DART.
这是那个天文里面非常常用的一个工具包。你看它的全身叫什么
？Into an asteroid to see if there's any slight change in its trajectory, and this collision will change the asteroid ever so slightly, so that if you got it
这个检测实在是太机智了，这是天文里面比较有名的一个，我觉得比较黄的一个检测。天文里面稍微不良的一个，里面专业术语实在太多了。
Revolving around another asteroid, it's going to ram it at 15,000 miles an hour and see if we can change that trajectory just a little bit. And DART is not only going to help NASA, but indeed the world prepare in the event that an Earth-threatening asteroid were to be discovered and we thought it was coming to Earth. So this is important. Go DART.
Thank you, Administrator Nelson. Joining us now is the director of NASA's Science Mission Directorate's Planetary Science Division. Let's welcome Lori Glaze to the NASA hangar, who just came from the Mission Control Center, watched the whole launch. You get to see all the cameras and the computers and everything. So first of all, I want to ask you, how was that?
It was really incredible, I have to say. Sitting there in the room with the headphones on, and you can listen to the spacecraft team as they go through all of their checks and making sure that they've got everything ready to go, and all the go for fuel, and then watching the monitors. You can see the fuel tanks filling up on both of the main booster and on the second stage, and then the final poll when you get, the spacecraft teams go for launch, and then you hear the launch team say, "Is NASA ready for launch?" And NASA launch manager says, "NASA is go for launch." And then I'm going to admit that I snuck outside and watched.
You got to go out.
And it was amazing.
Clear sky. You can see it the whole way.
Clear sky, lit up behind the hill there. Gorgeous.
这里的主播其实在发射场当地啊。
我
说刚刚说是发射前是跑出去室外看。
Your division, Planetary Defense Coordination Office is in there, and you've got the DART mission. What other missions are under the Planetary Defense portfolio?
So, great question. In addition to the DART mission, which we now have just launched, we actually also have a mission. I know you've been talking about the importance of detecting and characterizing asteroids. We have a mission that's called the NEO-WISE mission, or the Near Earth Object WISE mission, which is a repurposing of the old WISE mission that we actually use to do some detection of asteroids, but also a lot of characterization so that we know what the asteroids look like, what they're made of, and what their orbits are. And then we have a new mission that we just started developing that we're hoping to launch in the next few years.
总的来说，就是说它现在加速的是应该是一个抛物轨道，就是说可以逃离地球引力的一个轨道。
To looking for those near-Earth objects, that'll be its sole purpose. We're going to send it out to a stable orbit called a Lagrangian point.
这任务设计的时候，因为它是个低成本的任务嘛，所以它花了大量的时间设计它怎样去爬升轨道，你知道？因为它本来设计是一个次级载荷嘛，它本来是设计用一个，因为他们自己新自带那个下一代电推，缓慢的以一个非常聪明的方式，要避免掉、规避掉，尤其规避掉月球的潮汐力。一个非常复杂而且聪明的做法，去逐步爬升轨道到逃逸地球。没想到结果同样说我们给你包车送，然后一步到位，它这个整一个爬升过程就省略掉了，是蛮搞笑的。你现在去维基上去搜那个像 DART 的任务介绍，它会去介绍它的一个轨道爬升方法，很好玩，但那个其实完全用不到的。那这也是使得那个DART任务的时长会大大缩短。那么这整个任务就是大概11月左右，但明年9月份就能抵达那个DART系统。
Director of NASA Science Mission Directorate's Planetary Science Division, thank you for being here.
My pleasure.
All right, so with that, it's time to ask the expert scientists at NASA another question about the asteroids. And this one, folks, this one's for NASA asteroid expert Davide Farnocchia. We're going to ask him the question, is NASA aware of any Earth-threatening asteroids?
No, there is no asteroid that we know of that is concerning in terms of impact hazard. Now, we know that asteroid impacts have happened in the past and can certainly happen in the future. But we should keep in mind that those are rare events. An asteroid impact that could cause serious regional damage only happens every few thousand years or longer. Still, it's a good idea to protect us against that possibility, and the rule of the game is find asteroids before they find us. And that's why, for over 20 years, NASA has been funding search programs to observe the sky pretty much every single night to find and track.
他的介绍的是，就说是小行星威胁的介绍。现在来说是没有什么会进行大的冲击的一些小行星，在未来几年，就像这种会，就不是小行星能够大到不会在大气中烧掉并且砸到地面的，这种事件其实是比较少见的。能够形成比较就是直径上百米的陨石坑的这种撞击，可能要2-3千年才一次。不过，
The good news is that for all the asteroids that we've discovered so far, the Torino scale is 0, so lowest risk for the next 100 years. So,
现在目前为止发现的，可能是一定尺寸以上的小行星和地球碰撞的威胁性，就等级是0啊。 大概是1是在几个等级吧。
Now let's discuss the computer that will use Draco's camera and the images from it to autonomously fly DART into its target. Samson Rainey is back now with us from the Mission Operations Center in Maryland with a special guest to tell us more. Samson?
他们这边介绍一下它的
Joining me right now is SmartNav lead Michelle Chen. Michelle, give us some insights into what you call the brains of the spacecraft. How will SmartNav allow DART to identify its target and stay on that target for the whole 4 hours before impact?
Right, so at 4 hours is when SmartNav starts controlling the spacecraft. And if you imagine that you're the spacecraft and you're looking at the Didymos system, you're going to see the Didymos system and Didymos itself.
它是一个下一代的电推嘛，特别突出的是它的效率。
coming out from eclipse, and it is at that point that we start guiding towards Dimorphos.
Great. And so why did you choose this method for the mission as opposed to other alternatives?
So this method, we kind of need it because everyone's been talking about the 15,000 miles per hour. So that's 250 miles in 1 minute. And for us to joystick that from the ground with the 1 minute round trip light delay for communications, it would be impossible. So we needed something autonomous.
当地的进行决策，遥控是不行。
So how are you feeling right now? And how are you gonna feel, when we approach those 4 hours before impact?
Right. Yeah. So ATL has a lot of experience on the trend guiding technology, and SmartNav is a hybrid that we started in 8 years ago.
它按照它的原定发射计划，它是承担了一个爬轨的作用的，因为效率比较高嘛，需要它做一个有效的爬轨。但是因为空它做了一个包机直送之后呢，其实这个引擎其实说它原本的定位角色已经失掉了，但它也同时这个引擎也是作为一个新的引擎验证实验嘛，所以它还是会在过程中去进行几次点火。 那其实说有没有这个点火对任务的影响，其实是不太有关系的，因为它还有另外一套引擎系统。所以是一个比较有意思的事情。
And we have a fun way now, a little separation from the serious science, for you to participate in our mission today, and it's by signing up to be a planetary defender, just like Kelly. Here's a look at some of the people who sent us videos on how they got involved.
I'm a planetary defender. I love space, and my dog is also a planetary defender.
搞小孩子卖萌的事不光是小孩子，还有一个就是小孩子卖萌专场。
Yo soc defensor planetari.
看就是社交网络的一个参与。
io siamo difensori planetari. Cosmo and I are planetary defenders.
We're planetary defenders! I'm a planetary defender. Yeah!
Love the kid with the rocket engines.
It was great.
Yeah. If you would like to participate in being a planetary defender, there's a website. We're going to put it up on the screen. It's at dart.jhupl.edu/planetary-defender. Again, that's dart.jhupl.edu/planetary-defender. And there's a 5-question quiz. And then if you do well, you'll receive a digital certificate so you can share it on social media or, you know, hang it on your wall. So guess what? Daryl and Kelly took the quiz.
You did.
And we have our certificate. Look at that. Oh, yeah. I am officially declared a planetary defender on NASA's Double Asteroid Redirection Test.
I am proud of you, Daryl.
Thank you, Kelly. That means
这是他们网上的一个互动活动吧？可能。
I mean, you took the quiz, right? And you passed.
可能是应该是通过一个小测验，然后得到一个所谓的小行星防御者的认证，反正就是一个大众的和大众互动的娱乐活动，好像是。
And a video of me popped up. So, and by the way, our planetary defense officer Lindley Johnson, he also took it and he passed.
That is great to hear. That is great to hear.
哇，已经这画面已经这么赞了。你看，果然就说现在，因为它是一个抛物线轨道嘛，所以它其实离开地球离个还是蛮快的。现在已经是4000多公里了，所以地球景观已经看很不错了。我倒一下看看，非常不错。
Villanueva for more on this.
Thanks, Daryl. I'm here with DART Coordination Lead Nancy Chabot to find out what is next. Thanks for joining us.
Thanks for having me. Great launch, huh?
It's beautiful. So what is the first thing your team will do after impact?
We will be doing so much. I mean, first thing will be the Draco images that are streaming back 1 per second. And this is the first time we get to see what this asteroid looks like. And so I guarantee the team at APL is going to have these images up on the big screen, seeing what the shape is, seeing what the geology is, seeing where we actually hit. You know, but then there's more. There's Lychia Cube, and those images are actually going to take a few days or weeks to come back. And they're going to show us the ejecta from the collision. And the telescopes are going to get right to work too here on the Earth. They're going to be turning their gaze and trying to figure out how much we actually deflected this asteroid. And that's going to go on for months. And then we've got a bunch of people with state-of-the-art models. They're going to model the impact, model the ejecta, model the dynamics, and they're going to use the inputs from the images and the observations and all come together. It's going to be a really, really busy time.
Sounds like it. And can you tell me why the impact, the timing of the impact is important?
Yeah, it's really interesting because September 2022 is the perfect time to do this. So Didymos and the Earth, they both go around the sun, right? But it actually takes about a little over 2 years for Didymos. So sometimes the Earth and
这边停掉吧，看这边的画面，我再继续往前切啊。这个是2600公里。3000公里了，3000公里的画面，这个也不错。这个镜头还可以，3500公里不到，好爽啊！这就是看深空任务的好处啊，就。因为前一次的话，其实看到这种类似的画面的时候，就是像猎鹰重型发特斯拉的时候，对吧？你看后面那次特斯拉的2小时直播嘛，后来是发射回来，就其实蛮爽的。这镜头角度并不是说有那个，就是那个特斯拉 Starman 的那个角度那么酷炫啊，但还是不错的。可以看到明显的是高度升高之后的地球的边界曲率变化，就地球看上去越来越小了。这个你看，这个是4200公里对吧？这个已经看到绝大部分地球在这个镜头的视角范围内啊。这个看上去就很不错。 哦，这个镜头也可以。再往前切一点，5000公里高度。这个已经是最新的现场了，大概5分钟左右是到载荷的放出。哎，这个画面还是很有意思的。我本来说这边看宕机时间可能比较无聊，但对看看这种画面还是感觉还是不错的。这个确实还是1040p，但清晰度只有这样了。看是它传回来画面不会特别看，不是特别高清，通信还是有点。是有限的。看这个轨道，其实就是这算是一个逃逸轨道吗？严格来说是个，应该是一个抛物线轨道左右吧。就是你回顾一下高中的现代啊，是线性代数吗？不是，分析几何，对，应该是分析几何吗？反正就高中我们不是学过双曲线加速吗？就一般的轨道不就是，你圆形之后，你再多加点速，你可以变成一个椭圆，对吧？椭圆圆形到椭圆的变化你是知道，如果你再多加一点的话，加到一定程度的话，椭圆就会转化成抛物线。那其实就说是一个家族里面的，还有抛物线的话，就是基本上就是逃逸的定义了。你就想象，就是你不断加速之后，椭圆的远地段就是越来越大，越来越大，然后到了某个境界之后，它达到了无限了，就是不再闭合成一个椭圆了，那就成为了一个抛物线。哦，6000公里了，这个角度地球比较亮啊。会不会出一个镜头能够完整的看到整个地球在那个镜头的视角之内？有可能的。哟，好帅啊！看一下啊，这个镜头能多保留一段时间的话，说不定看到一个完整的地球，还是稍稍有点不够。镜头也得不断切啊，就即使跟地面其实有好的通讯的话，那么因为飞行器或者2级的话也是在旋转当中嘛，多少有点旋转，所以它跟地球能够互相通信，就是说天线。你想天线朝向跟地球能够互相保持良好通讯的地方，可能也是会几个天线之间相互切换嘛。看一下，其实感觉地球是放得下的呀，在这个视野里面。沉迷于看这个。大家感觉散光了，人都好像都散光了。看一下，还有2分钟是载荷的放出，我就把这个画面放在这了，去看看还算有意思，还不错。看看推，快了，还有1分钟，估计主播快回来了，估计。
acquisition of signal. Goodbye.
Welcome back to our launch coverage of the DART mission for NASA. If you're just joining us, we had an on-time launch at 10:21 p.m. Pacific time, followed by successful ascent stage separation. First stage landing,
反正一个非常好的起飞和1、2级分裂，2级点火等等。1级是顺利着陆了，开始没有给画面，但在第2次点火重新2次点火之前，我们看到了1级的驳船着陆画面。我们现在终于来到了发射后55分钟半，现在即将进行的是载荷的放出。现在随着高度其实已经来到了7300公里啊。它现在处于的是一个抛物线轨道，所以它的高度上升得很快。好，放出了载荷，放出。在一个太阳的背景之下，完成了这次载荷的放出。完成。
The impact of the DART spacecraft with the small asteroid Dimorphos is scheduled to happen sometime between the end of September and early October in 2022.
当然，就是说发射部分就是完成截止。那么这枚飞船本身呢，还会经过11个月的飞行，然后在明年的9月份左右抵达它的目标撞击系统，就是又忘了，反正那个小的那颗叫 Metamorphosis，还有小的那个大的那个叫 Didymos， 反正明年9月份会到达目标的双星系统来完成它的撞击实验。那么这次发射任务的话，应该到这里就已经结束了。
And with successful payload deploy, that brings our webcast to a close. For continuing coverage of the NASA mission, head on over to nasa.gov/live or check them out on their social channels.
之后呢，就说是 NASA 那边直播应该会去，因为还会一系列的检查动作、太阳能板展开等等。但我们这次我们就看到这里了。感谢大家收看啊！那么也就是感谢现在还在看的几位观众，我们这次任务就看到这里结束了。如果有什么后续的话，我可能会在专栏里面再继续补出来。那么这次任务就看到这里结束了。好的，谢谢大家的收看，喜欢的话请点个赞，那就到这里为止，拜拜。这画面还可以哈。最后再刚才视频已经关了，这补充一下吧，就是2级应该是不会，是不可能再载入了，像这种任务的话，应该是会之后呢是稍微推一下之后呢进入一个 graveyard 的 orbit， 反正就说是防止它再重新撞回，就是干扰到其他卫星的运行嘛。其实像抛物线这种稍微偏一下就能够偏到一个相对比较可以接受的轨道范围啊，反正就是这么一点内容，大家就这次就看完了。大家下次见吧，拜拜。